Okay, now we are down to the last feature of the periodic table that we're going to be looking closer into. We actually covered the group 1 metals, we covered the group 7 metals, group 1 metals or group 1 elements, which is known as your alkali metals. We covered the group 7 elements, which is known as your halogen. And last one we're going to cover is the group 0 elements, which we will call the noble gas. Okay, so there's only 3 groups that we are looking at: group 1, group 7, and group 0. These are the only 3 in your syllabus. So at the end, at the end of this thing, you discover that group 0 elements are unreactive. So they're actually quite boring elements. Okay, not many reaction. Okay, you also will describe the lack of reactivity, or why it doesn't react or why it's unreactive, in terms of the electronic structure. Okay, so let's look at it closer into it. Now, group 0 elements, they are known as your non-metals. They form only 1% of the Earth's atmosphere. And obviously they are known as inert gases or noble gas. So from the name, noble gas. It's so noble that they do not want to react or marry with any other elements. So lame. Now, what is the thing about noble gases? They are colorless and they are odorless. Okay, boring. Okay, they have low melting and boiling point, which generally means that they are gases, which is also reflected by their name. Okay, they are also insoluble in water. When you put them in water, they will not react, they will not dissolve. Okay, so you can see here, it's like almost not reacting, no colors, low melting and boiling point, makes it boring. But because it is so boring, it is so unreactive, okay, because it is so unreactive, what we do is we put it inside things that are very reactive. So such as your neon lighting, your light bulb, we put the noble gas in so as to make sure that the things inside our substance doesn't react with the things outside of the substance. So example, we talk about the filament here doesn't react with the oxygen in the air. Okay, inside this tube, we put some neon gas. Okay, we generally use it for lighting, okay, by having different concentrations of it and stuff. Okay, mixed with also other elements here. They will not react. They are very nice people. Neon. Okay, very unreactive, very boring. Okay, next. What's the special thing about the chemical property? Obviously, they are boring. They have no chemical properties. Okay, why do they have no chemical properties? Look at this. Come on, look at this. Electronic configuration 2. First shell, fully filled. Next one, neon, 8. Second shell, fully filled. Do they want to react? No. Next one, argon, 8 electrons in the valence shell. Do they want to react? No. So we call it duplet, octet, octet. Generally, it just means, okay, we call it the noble gas electronic structure, which actually just means that this means the valence shell is fully filled. Okay, valence shell is fully filled. So noble gases actually have stable electronic structures. Okay, stable electronic structures. And because they are stable, they are chemically unreactive. Okay, they do not react. Why are they unreactive? Okay, you can think of it this way. Why are they unreactive? Because they do not lose, gain, or share electrons. This is the main thing here. Why do they not lose, gain, or share electrons? Because they are unreactive. Okay? And because they do not lose, gain, or share electrons, they do not form compounds. And because they do not form compounds, they exist as monatomic gases. Which means that they exist as single atoms. So one is the effect of the other. Unreactive because why? They have valence shell fully filled. The valence shell is fully filled means they're unreactive, which means that they will not lose, gain, or share electrons, means that they do not form compounds, means they'll exist as monatomic gases. So noble gases generally boring. Okay, what kind of typical question they will ask? So why noble gases are unreactive? What you need to say is they do not gain, lose, or share electrons because they have the valence shell fully filled. Okay, that's all. Simple. So with regards to it, okay, We will look at some of the concept maps here. Periodic table has groups, has periods. Group tells us number of valence electrons. Period tells us number of electron shells. Okay, number of valence electron, number of electron shells. Okay, the periodic table elements are arranged according to increasing proton number. Next, we dwell into the metals and the non-metals. Okay, this part here, transition metals, can forget about this. Okay, this is not your syllabus. Color. Okay, we will just be looking at the group 1 metals, group 7, and group 0. So group 1 we know low melting boiling point, low density. As you go down the group, reactivity increase. Okay, they react with water, they are good powerful reducing agents. So this one is your physical properties. This is your chemical properties. Next up we look at group 7, which is your halogens. Okay, fluorine, chlorine, bromine, iodine. What are some of the physical properties? Diatomic molecules. They have low melting boiling point. The color becomes darker down the group. These are all your physical properties. What are the chemical properties? Okay, it undergoes displacement reaction. Okay, displacement reaction. It is also a powerful oxidizing agent. And last one, we talked about the most boring one, which is noble gases. Okay, boring, unreactive, they do not form ions, molecules. Why? Because they have their valence shell fully filled. So just take note of this. Okay, so with regards to all of this here, okay, this marks the summary, okay, of our periodic table. So that's all.